Okay, I wanted to make a video real quick with doing some examples of limits. Now, I want to do one with graphs first. Graphs are probably my personal favorite as far as like finding limits because visually it's so easy to get limits. And essentially, what we want to do is kind of make a wall on our graph or like a make believe wall that we'll kind of run into or hit as we're approaching a certain value. So like let's say we have this example right here, and this is the x value of 1 right here on the graph. So we want to like approach that number right there from the left and the right. So we're basically wanting to find the limit as x approaches 1. We'll do it from the left first. So for whatever the function, this piecewise function, we'll just call the whole graph itself f of x. So for f of x, this function, okay? Now, what I essentially do whenever I'm trying to find the limit is I go to the x value that I'm looking at and kind of throw up a wall. So let me draw in kind of exactly what I see going on here. And it's so hard. I'm trying to draw a straight line here, but, okay. This is going to be my wall right here that I put up so that when I'm approaching, getting closer to 1, I want to get closer and closer to this 1 right here on the x-axis, and then kind of see what do the y values approach for this graph, okay? So if you look here, if we're coming from the left side, this is the graph right here. And we'll be traveling on the graph kind of downward right here. When we get to 1, we're going to crash kind of in this region right here. This crash point is 1, 0. So 0 would be your limit from the left side. So that would be your left side limit, okay? Now, what about if you're coming from the other side, the right side, okay? Well, on the right side, you're going to be traveling on your graph. This way, you kind of come downward here, and then we're going toward the wall. We're going towards the purple wall here, and we crash into the wall about at this point. Make it kind of large here, about this point right here. This is going to be the point 1, or it would be the point we crash at 1, 3. These are each little two blocks make 1, it looks like. So 3 would be what we say is the limit from the right as x approaches 1. Run 1 from the right, okay? And by the way, how do you know if a limit exists? Well, a limit exists only if the limit from the left side and the right side equal each other. Right here we can see the left side is going to be 0. The right side is 3. So you would actually say the limit as x approaches 1, just 1 by itself, not left or right. We're going to say it does not exist because the limit from the left and right are different numbers. We'll do one more example, but the graphing ones I think are definitely going to be your favorites because they are very simple to do once you get the idea of the wall kind of mechanic. So let's go down here and look at another place. Let's do right here. Let's do at 2. So we'll do the limit as x approaches 2 from the left and the right. And then we'll find x as the limit as x approaches 2 from both sides. So, or limit as x approaches 2 just in general. Okay, so what I want to do first is put up my wall for my graph. So 2, I see 2 is right here. So I definitely want to throw up my wall in this region. So I'm going to put my wall going down through 2 like this. So this is my wall. You're kind of imagining this in your head, but here I can draw it physically for y'all. And now what we want to do when we do these limits from left and right, is we want to travel on our graph. So from the left side, so you're coming from the left, so you want to approach 2 from the left, okay? You're going to be crashing into the wall right here about at this point, 2, 3. So 3 is going to be your limit. As x goes to 2, the function itself looks like it's getting closer and closer to 3. Okay? And then let's say now you want to go from the right side. Okay? Let me use a different color than green here. So when we come from the right side, we're kind of going down this hill, this little bitty hill. So this is from the right side. And you're traveling this way, right? Like you're going this way. You're traveling toward the arrows. And it looks like you're going to be diving down to that same point, 2, 3. So that limit is also going to be 3 because you're going closer to that point. Since those two are equal to, you'll say the limit at 2, as x approaches 2, just the flat 2, will be 3, since those two values are the same. Okay? Now, let's look at some graphs where you're going to have limits that are not actually numbers, but a lot of times they may be infinity signs, like negative infinity or positive infinity. So let's look at, we'll do 2 examples, one with a vertical asymptote and one with a horizontal asymptote. So like, let's say we're looking at this region right here. We're going to approach -4 on the graph. So we're going to use this graph and we want to come at -4 from the left and the right for this particular graph. Okay. Well, let me look at doing the left side first. So the limit as x approaches -4, and then we want to have from the left side. So put your little minus sign. We'll just call this function the whole graph f of x. Okay. So what we're going to do here, the graph is up here, so it's like up in the air, and we're going toward -4. So we want to move on the graph till we get to -4. Now this graph, it looks like it stops right there in the air, but it actually gives you the impression it keeps on going. So it'll actually keep on going, and it'll keep going, soaring up, 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 until it gets closer and closer to this like dotted line, which is a vertical asymptote. That's what the dotted lines will symbolize when you see a graph like this. Well, since it's going up forever and ever, the limit as x approaches -4 from the left side would be positive infinity, since it's going up. The graph keeps on going up forever and ever as you travel on it from the left side. Now, you'll do the same thing to get the limit from the right side. So limit as x approaches -4 from the right side. Well, for this one, our graph is down here, so we're going to travel this way. So I'm just going to do some little arrows, green arrows here. You know, I'm traveling on the graph down this way, and this graph is falling, so it's going to keep going down and down and down forever and ever until it gets closer to that dotted vertical asymptote. Well, it's going downward to negative infinity on the y-axis. So this is actually going to be negative infinity as that limit. Now, just like before, if you have limits that don't match, like these, one of them is positive infinity and one of them is negative infinity, the limit overall, if it's not the same limit on both sides, it's not going to exist. So you'll say the limit as x approaches -4, just in general, just -4 flat, it does not exist. So DNE. Okay. Now, if both of them ended up going like upward or whatever, then you'd say positive. If they went up on left and right, like it went up towards the sky on the left side and the right side, you would say like, you know, the limit is positive infinity. But this one, it don't match. So it works the exact same way as as the limits from the last examples, the ones that had like numbers. Now, I want to do a horizontal asymptote as well. You'll see a horizontal asymptote on this next example. It's this dotted line right here. It just keeps going out forever and ever. So this is your horizontal asymptote right here. And if you like kept on drawing this graph, basically what you're going to have happen is this graph would keep on getting closer and closer and closer to this horizontal line as it keeps going out. So that's how horizontal asymptotes are working. Also, back here on the left side, if you have the graph, this side of the graph, it would be coming down and it'd be getting closer on the back end to that horizontal asymptote. Now, with horizontal asymptotes, generally they make you only look at one direction or the other. They'll make you either look at as x goes to positive infinity or as x goes to negative infinity. And a lot of times they are going to be the exact same number, at least for the functions that y'all are working with in this class. But like, let's say you want to do the limit as x approaches negative infinity. So you want x to get larger and larger. Now, the x-axis, you know, it's the horizontal axis. Negative infinity would be like way, way back here. So you'd have to keep going past negative 10, keep on going forever and ever and ever and ever. You'd never really touch it, but, you know, you're going in that direction. Well, on the graph, we're going to be traveling on the graph, you know, kind of downward this way. So the graph is going down, and it's going to keep going downward until it gets to this y value of -3. Now, it's never going to touch it. There's never going to be a value there, but that's not really what limit's about. Limit's about what are the values approaching, and the y values are shrinking. They're getting smaller and smaller and smaller till they almost get to 3. To positive 3. I didn't mean to put out -3. But to positive 3. Okay. Now, you can also do the limit from the as x goes to positive infinity. That's just going forward. Let me do one of those for you right quick. Running out of colors here. So, let's say I want to do the limit as x goes to positive infinity. So, I want to say my x value is going to get larger and larger. Well, positive infinity for x is going to be out this direction, the forward direction. So, like, you know, you keep going this way. You want to keep moving this way to infinity on the x. Well, on your graph, you're walking on your graph. You know, you're going this direction right here with the arrows on your graph. And your graph is actually getting closer and closer to that horizontal asymptote, which is the value 3. A lot of times the horizontal asymptote, or the limit for these infinities, will be similar on the left and the right side. And those are the ones for horizontal asymptotes. How you know if you have a horizontal asymptote or not, if the limit as x goes to infinity is approaching some kind of number, negative infinity or positive infinity. Okay, and the very last problem that I want to do is one where you have to calculate a limit of some kind of function using a table. And I really like the table ones because they give you an idea of what the limit is, like in terms of like getting closer to certain values. So let's look at this example right here, and we have to set up our calculator just a little bit before we're able to tackle this kind of problem. So what I want you to do when you go and use your calculator, you want to use your calculator to always do the plug and chug problems. So we want to go to table setup. So you're going to hit the second button and then window. So you want to hit second window. And we want to make sure our table is set up to where we ask for the value. Okay, so we want it to ask us for the independent variable. And this will basically let us put in values for our x instead of, or for our x instead of auto-generating values maybe that we don't really care about that much. I want to put in that function x cubed plus 1 and then divided by x plus 1. So let's go ahead and go to our calculator right here. And I'm going to go put that into y equals. So you want to hit the y equals button right here. Okay, and you can do this a couple different ways. You can do it where you do parentheses x to the third and then plus 1 divided by and then x plus 1. So you can do it like that, or you have it in parentheses like that right there. Make sure I got down the function right. Yeah, that's right. You can also make it to where it looks like a fraction too. Some people do like this. It helps them out better. Like there's a fraction on the newer versions of these calculators. There's a fraction format. So if you hit alpha and then F1, you can actually go. It's number 1 right here, the n over d thing. If you hit that, it'll kind of set up fractions for you already. So you can make it look a little bit better maybe if you're interested in that, or you want to make sure you're dividing by the right things, especially if you're kind of iffy on like your parenthesis placement. So there's our function right there. Now, for us, we're going to go into second and table, and basically now mine is cleared out, but if you have numbers here, you should be able to delete them. But since you put independent variable as ask, you'll be able to actually plug in values for x, and it'll give you the output. So let me see what they have us to plug in. And if you look here, it's wanting us to find the limit as x goes to -1. So what we want to do is we want to approach -1 on the left side. So this is approaching -1 from the left. So approach -1 from left. Okay. And we'll see what this ends up giving us, and then we'll do the same thing from the right side and see what happens there. Okay. So we just want to put in those values: -1.1, -1, -1.1, -1.01, and I think the last one was -1.001. So we're almost really close to -1. And you might be asking yourself, like, oh, why don't you just put in -1 if you want to see what the limit is? As x goes to -1, why don't you just put in -1? The idea of limits is actually not touching the number, but if you did have the idea of like doing that, a lot of times you end up getting errors when you put those in like that. Not for all functions. Sometimes there are points at those places, but just in case there is not, like in this problem right here, this one you can't actually plug in -1 to the actual function. -1 is not in the domain. So just in case you were wondering about that yourself, just be cautious of that. So that would be the values that we put in our table for those 3 numbers right there. Okay. And I don't know if I can remember those or not, but I'll try to. So there's our values right there. And then we want to do the same thing now. And let me just say this, like that, what we just found, that's the limit. Let me write it in purple, actually. This would be the limit as x approaches -1 from the left side. We found it to be, it looks like it's getting closer to 3. So we would say that's 3. Now, let me do here in a different color. Let's say we want to look at the right side. So we're approaching -1 from the right side now. So we're getting kind of smaller as we go. And I usually like to go from the largest here and then go downward. So I'm going to start with -0.9 and then go that way. So this is approach -1 from right. This is basically us finding the limit as x approaches -1 from the right side. And like this is why I say the tables, I think, give you a better idea or a better feeling for that whole idea of approaching. So I think this is the homework problems start with the tables, just because plug and chug is relatively easy, especially with these calculators. But the graphs, I prefer the graphs actually a lot more, even to the plug and chug ones, because you can just kind of look at those. But we want to start out with -0.9. And then I want to get even closer, so I'm going to do -0.99. And then get really close to -1. -0.999. It looks like we're getting closer to 3 on that side as well. See if I can remember these three numbers. 2.71, that we get closer. It looks like we're getting closer to 3. So on both sides too. So from the right side, we get closer to 3, and on the left side, we get closer to 3. So the limit as x approaches -1 in general, since it's equal on both, it'll be 3. So this would be limit as x approaches -1 just in general would be 3. And that's how you use the calculator and tables to find these limit problems.